For problem 10 of the AIME 2 2026, is asking for us to find the greatest possible value of BC when all of the triangle sides AE, AF, BD, and CD are all positive integers. Now, the power of a point at BC is our first step. So, since omega is tangent to BC at point D, we have power of omega B equals BD squared. So the power of omega C equals CD squared. Now, because line BA intersects with omega at A and E, we also have so that equals 200 times 200 minus AE. Hence, BD squared equals 200 times 200 minus AE. Now, similarly, line CA intersects with omega at AF, A and F. So the power of omega at C equals CA times CF, which equals 225, brackets 225, minus AF. Therefore, CD squared equals 225. Now, let's convert the integrality into square conditions. So, let BE equal 200 minus AE, and since AE is a positive integer, BE must be 1, 2, till 199. So, from 1, BD squared equals 200 times BE, which equals 2 to the power of 3 times 5 squared times BE. Now, for this to be a perfect square, we must have BE equaling 2s squared, and for some integers that's s greater or equal to 1, BD squared must equal 200 times 2s squared, which equals 400s squared. So BD equals 20s. Now, BE also implies that is B smaller than 2. B being less than 200 also implies that 2s squared must be smaller than 200, so s must be less than or equal to 9. Next, let CF equal 225 minus AF from 2, so that CD squared equals 225 times CF, which equals 15 squared times CF. So, CD is an integer if and only if CF is a perfect square. Therefore, CF equals 2t squared. So CD equals 15 t. So then since t squared is less than 225 and we have t less than or equal to 14, thus BD equals 20s. So 1 is less than or equal to s, which is less than or equal to 9. CD equals 15t. 1 is less than or equal to t, which is less than or equal to 14. Now, using the angular bisector theorem, because AD bisects angle BAC, BD over DC must equal AB over AC, which equals 200 over 225, which then equals 8 over 9. Now, once we substitute 3 and 4 into the equation, we get 20s over 15t equals 8 over 9, becoming 4s over 3t equals 8 over 9, which simplifies to 3s equals 2t. Now, so s is even, so we can let s equal 2t. Then t will equal 3k. So 2k is greater or less than or equal to 9. K, therefore, must be less than or equal to 4, since it must be integers. And then 3k must be less than or equal to 14, so k must be less than or equal to 4. So k could be 1, 2, 3, and 4. Now, we have to find the maximum of BC. So we have BC equals BD plus DC, which equals 20s plus 15t. So that equals 20 times 2k plus 15 times 3k. This then equals 85k. Now the last step is just to substitute in the maximum value of k, which is 4. So 85 times 4 equals 340. And that's the final answer.